Hello everyone. In this video we're going to start to talk a little bit about variables in C programming. And what variables are they are spaces in memory that hold values that we can change and manipulate into programs to do useful things. In this video we're going to just talk about a couple of the basic ones, the char and the int. So let's go ahead and get started. Here I've written a program that's going to both demonstrate the use of variables as well as find the minimum and the maximum value that a variable can hold experimentally with a function. I'm not going to go into functions in this video, and we're just going to talk about the variables themselves. So we're going to start down here, and I will go over the functions in a future video, but right now this is how we create a variable. First we need to identify the variable type. So in this case it's a char, or also pronounced char. It's short for character, and it is this variable type is 1 byte in size, and 1 byte is equal to 8 bits. And if you're not quite sure what that is, basically computers speak really one language, binary, ones and zeros. And so this is a series of 8 ones or zeros. And really when you get down into the hardware level, it's really high and low voltages. Those ones and zeros are used in programs to represent high and low voltages on the hardware. And what a variable is it's a space in memory, and memory is a series of high and low voltages. And so each bit represents a high or low voltage at a point in the memory, and a char is 8 bits. And you could always, if you want to calculate how many different values are possible in a data type, if you know how many bits are in it, you can raise that 2 to the power of the number of bits, and that'll tell you how many possible values there are. So 2 to the power of 8 is 256. So a char can hold 256 different values. And so remember 2 raised to the n for later. All right, and so the maximum value for this, and this is a unsigned variable type, so it's only positive numbers, and it goes to 255. Now wait a minute, I just said up here it can hold 256 values, so why is the maximum value 255? Well, the reason is because we start counting at 0. So it's any value from 0 to 255. All right, so getting back to how you declare it is, first we define the type, and that reserves the correct amount of space in memory, and then we give it any name we like. Well, that's kind of true. We can use any letter number combination or underscores. We can't use other special characters, and it needs to begin with either a letter or an underscore. So as long as we follow those rules, we can use any name we like. And one convention that I'm using here is a camel type, or a camel case, where the first word is all in lowercase letters, and then each subsequent word is capitalized and they're all squeezed together like this. Now another way to do this is make it stand out would be to do this and put underscore in between each word, and that allows us to use a multiple word name, something that is meaningful to us. So here I'm making it 1 byte max, because I know this is a byte one size. The size of this is 1 byte, so it's 1 byte max equals 255, and I can put any number I want in there, but it's for now I know that the maximum value of this is 255, but I'm gonna get rid of this because my program won't work if I leave those in there. All right, and so in this method, this way of doing it, we're assigning the value to this space in memory, given this name, at the time that we're actually creating it. And every line in C ends in a semicolon here, or just like you see here. Now another way to do this is we can reserve the space in memory and first without assigning a value, and then assign the value later. In this case, I'm calling this one 1 byte min, and I'm not assigning the value here. I'm actually down here when I'm assigning it down here. Now notice now once it's declared with the type here, I don't have to use this anymore. I can just use the name. So on this line, I'm just using the name 1 byte min, and then I'm using the equal sign to assign the value 0 to that space in memory. Okay? So that's how we create a variable. Down here, I'm just creating another one, and I'm calling it another byte. And we can also assign the values of other variables to our variable. So here, I've declared it here. Now I've assigned a value to it down here, and it's equal to 1 byte max, which is up here, divided by 2. Now I could write 255 divided by 2 here, and it would do the same thing. So because this 255 is assigned to this right here is the same as 255 divided by 2, and then that's assigned to this space in memory that's called another byte. Okay? And when we run this, you're going to see something interesting here. And we'll get to that when that happens. Now, I was going to go over strings and arrays in this video, but it got really long, so I'm going to skip over this for now. Just right here in these lines, if you're wondering what they are, I'm just creating some strings, which are basically how you write words. Again, I'm not going to go into this in depth. This is for another video, but here is where I'm actually going to print the values to the screen that I created up here. So on this line here, I'm going to print the value of 1 byte max. And on this line here, I'm going to print the value of 1 byte min. And then down here, I'm going to print the value of another byte. So it should be 255, 0, and 255 divided by 2. Okay. On these two lines, I'm actually going to do something called, it's very similar syntax here, but instead of inserting the variable name here, and notice up here I'm using the variable name, and that's the nice thing about variables. Anytime we want to access that value, we just need to remember what the name is, and it does need to match exactly. It is case sensitive. That was something I forgot to mention earlier. So it has to be exactly the same as I use up there, or it won't work. But down here, instead of putting in a variable name, I'm calling it a function. And we'll talk about functions later, but basically wherever you stick a function, if it returns a value, it's going to stick that value right in its place. So that's what this is going to do. This function is going to go run some functions, and it's going to find what the maximum value of this data type is, and it's going to print it on this line right here. And then down here, this function is going to go find the minimum value of this data type and print it up here. So we're going to actually experimentally test the minimum and maximum values for this data type, or this variable type. Okay? And it's going to print to the screen. Now, I said it was the max was, up here I said the max was 255, the minimum is 0. So we'll just see if it works out to be the same there. All right, now the int, or short for integer. Now here, I am creating it. Again, I'm giving it and saying what kind of variable it is. In this case, it's an int, and I'm calling it whole number max, and I'm making it equal to this int underscore max. And you might wonder what that is. And what that is that's a constant from a library, and it's from the limits.h library. And I could go show that to you, but just know this is a constant, and it's traditionally a good practice to make all your constants in all caps like this. And we'll cover constants after we cover variables, but int max is a value stored in a library, and if you haven't watched my video on libraries, you can go look at that, find out what libraries are, and it's just going to load that value here. So whatever that library thinks is the maximum value for an integer, it's going to place that here. And I'm doing the same thing down here as I did above. I'm declaring it first, and I'm assigning the value. I'm assigning the int min value to it. Down here, now this is let me pause this for 1 second here. And an int is a signed value. There's a signed data type, meaning it can have both a positive and a negative value. And so down here we should see a negative number, and up here we should see a positive number. If we want to just use positive numbers, we can use an unsigned int. And then, so I'm calling this unsigned int positive integer max. And the reason why we might want to use an unsigned instead of a signed is we can have the maximum value can be twice as big. If we have negative numbers, well, half of the numbers are going to be negative, half the numbers are going to be positive. We can only have so many values, so the maximum value is lower than unsigned value variable type. So there we have 3 different variables there. They're going to get printed to the screen down here. Okay, and again, I'll go into a little bit more about input-output like this later. And then again, down here, I'm going to call some functions that finds the minimum and maximum values experimentally. So here, this function is going to go find the maximum value of an integer experimentally and return it, and it's going to print on the screen. And it's going to take a little while, and you'll see. And then down on this line is going to find the minimum value of integer and print it here. And remember, that should be a negative number. For an unsigned integer, I don't need to find the minimum because I know it's 0. 0 is going to always be the minimum for an unsigned number. And then, but we are going to find the maximum value. Now, this number should be about twice as much as this number here. So let's go ahead and run this program, and we'll see what it does. I better compile and build. Now I'll go ahead and run. Okay, so you can see that it up here on these lines, this is it, the program printing those values to the screen. These are exactly the values that I entered when I declared this variable type. Okay, so 255, 0, and 127. Now wait a minute, 255 divided by 2 is 127 and a half. Well, the reason why it just gives 127 is these 2 variable types that we're working with, the char and an int, are whole numbers only. So they cannot hold fractional numbers or decimal places. And when you just do this, it's going to give you the lower value. So in the case of 127.5, you're just going to get 127. You need to keep that in mind when you're dividing with whole number values like this. In the next video, we'll talk about the float and the double, which are floating point variables, and that's where we have decimal places. Okay, so down here, the program found the minimum and maximum value experimentally. You can see that we were correct. The maximum value is 255 and the minimum value is 0. And it did it relatively quickly because they're small values, and it didn't take long to find them. Down here, these 3 values are printed directly from the values we entered, and they showed up pretty quickly. You see a positive number for the maximum of an int and a negative number for the minimum value. I'm not going to read that out for you. It's a big number. And then you can see that an unsigned int is twice as big as the int. Now down here, you can see 2 lines have showed up already. But if you've been watching, they've been just popping up real slowly, and that's because the function that's how long it takes to count to this value. And that's actually what the function is doing. It's counting, and it's iterating that value until it does something called rollover. And I'm going to demonstrate rollover here as soon as we're done with this right here. But basically, it's counting to the maximum value or minimum value, and then reporting it here. And it's still trying to find the maximum value of an unsigned int, and that's going to pop up in just a second. See, 1944 is the time. I might just pause the video, and then I'll start it back up when this shows up. All right, so it only took maybe another 30 seconds or so, but I clipped out a few seconds so you didn't have to sit here and just listen to silence. But you can see that the Pi in your activity bar here, Pi was running at max capacity while it was finding that value, and it took quite a while to count that high. And now it's relaxed a little bit, so because the program is finished. I'm going to go ahead and hit enter to exit out of this. And now I'm going to tell you about a little bit how rollover works, because the reason why we need to know how large our data types are, where our minimum and maximum values are, so we can avoid accidental rollover. Sometimes it's or overflow. I'm sorry. Sometimes it's overflow is useful, and we'll use it intentionally sometimes. But if it happens unintentionally, you'll get unexpected results, and your program might crash, or just give you wrong values. Up here, I had this line commented out, and that's something that's common to do in programming, that we can comment a line to add it or remove it to our program. So we're going to add it back in here. And all I'm doing here is I'm changing the value of 1 byte max. Now this might seem strange, but you can do math on a value and then assign the new value back to itself. And this is a way to do that. Now, remember, we said the maximum value of 1 byte max of this type is 255. So what happens if we add 1? Well, I can tell you that it's going to go to the minimum value because it's going to roll over, or it's going to overflow. And so let's rerun this program and see what happens to this message. Okay, now remember down here, 1 byte max is going to get printed to the screen, and so instead of it showing up as 255, it's going to show up as 0, and I'll show you that in just a second. There, you can see it now says the maximum value of a char is 0, and that isn't right, and that's because it rolled over, or it overflowed from its max value to its min value. And that's kind of like it, yeah, it's just something you need to be aware of, and that's the reason why we're finding these values. Now, why did I really have to do this experimentally? Well, the reason is that there are some standards for how large these different data types can be or should be, but they're not always followed. And I've worked in some environments with some tools that might have different rules for these sizes. And so if you're working with an IDE or a compiler or a different operating system, or a different factor in your environment, it's a good idea to try to figure out your actual minimum maximum values experimentally, just to make sure they're what you think they are. All right, so I'm not going to make you sit through this again. That's about it for this video. In the next video, we'll talk about the floating point type variables. If you like this video, please click like. It motivates me to make other videos just like it. If you want to find out when I post more videos, please subscribe. You can also read about completed projects on our website, spaztech.net or spaztech.com. On our website, we include details of how we did some of the projects that are on these videos and some of the source code that you can use yourself as much as you like. If you want to track progress of projects we have going on step by step, be sure to check out our pages on Twitter and on Facebook.